All right. Thank you guys for the patience. So I'm going to talk to you today a little bit about intelligent zoning. So this does get a little technical. So for those of you who are faint at heart, please bear with me. But if you have any questions at all throughout the whole time, please do let me know. And this was taken from one of our bootcamp series as well too. So looking at intelligent zoning, leveraging machine learning. So I'm going to go through a couple of machine learning concepts and how we're identifying and classifying zones automatically. So basically, quickly what we're going to go through today, I'll give you an overview and impetus why we're looking at this. Then I'm going to go through two different problems. One is zone identification, and that's using unsupervised learning to identify different zones. I'll give you a bit of a background and a quick demo. And then classification using supervised learning. And I'll talk to you, walk you through each of these different concepts as well. And this is meant to provide you with a framework using an example with a specific demo customer. So you could take this to other customers, or if you're a customer yourself, you could apply some of these techniques as well. So our learning objectives for today are to look at using unsupervised learning to geographically cluster different points to arrive at a zone automatically based on the vehicle's movement. And then what we're going to do is we're going to look at those zones that we've created, automatically classifying them as a different type of zone. So what I'm going to do is I'm going to start with this specific customer at hand. So for those of you who are familiar with Geotab, obviously we have a second harvest database. And this is a customer of ours. It was a charity. We don't charge them for this at all, but they allow us to leverage and use some of their data for demonstration purposes. And essentially what Second Harvest does is they've got a series of trucks that go and pick up food from grocery stores that may be just about to expire, maybe some of them not, and then they'll go and deliver them to different agencies like schools and churches and this kind of thing. They have about 15 different vehicles, so not a massive fleet, but it provides a nice example for you guys of what we're trying to do here. So the agencies are the folks who are recipients of all that food, and the donors are the grocery stores, that kind of thing. So they need to kind of optimize the time they spend in delivery and pickup, but a lot of times, and what we find is our customers don't even know where their actual customers are, because Google Maps and everything doesn't do a really good job of identifying those locations. And a very simple example of that, in today's world in MyGeotab, how we're creating zones is you can manually create a zone yourself, or you can automatically add a whole whackload of zones by importing those geographic locations into the system. The problem is that, if you're a delivery vehicle here, this is an example around my hometown in Oakville, where this is a golf course, and the address location is, say 123 Main Street, but the clubhouse is, a kilometer, 2 kilometers down the road. So if you're trying to run any analysis on when is the best time to deliver to the clubhouse, am I going to be backed up or whatnot, you don't even know, because you're looking at the wrong geographic location because it's not zoned off correctly. So let's look at zone identification leveraging AI. So simply by driving around, I'll be visiting a series of points. I've got a Walmart location as a sample here, and there's a cluster probably by the loading bay and another couple of points very close. And the first idea is to identify that zone leveraging clustering algorithms. And then the second point is can we automatically label that zone as a donor or an agency? And you can think of using this technique to apply it to all sorts of other scenarios. It doesn't have to be binary. It doesn't have to be donor or agency. It could be distribution center. You name it. And there's different. I'll show you some techniques to automatically pull that data out so you can figure out how to do this in a nice and easy way. So many benefits to intelligent zoning: less resources required to manually update a lot of these zones, configure them, less manual intervention. And with these more accurate customer locations, you can optimize your delivery routes quite a bit better. There's more input that is necessary for route optimization, a better customer experience, and then improved vehicle usage through fuel and utilization if you get these zones actually correct. So the first part here is we're going to, again, try to cluster these points together based on a lot of the trip data. So we're taking individual trip level data from MyGeotab, right? And we're looking at the stop points, and we're clustering these in a specific area. But it's not a simple technique to do that, as many of you may know who have dealt with the data. So there's some popular clustering techniques that we leverage and can use, and some of them are something called K-means clustering. Basically, what you have to do for K-means clustering, you need to know how many different groups you want to actually cluster. In this case, there are 3 groups here, so we would say the K would be 3. You could do 5 groups, 6 groups, whatever. But in this case, you do need to know the number of groups you're looking for, the number of clusters. In this other agglomerative hierarchical filtering, again, clustering, you still need to know the number of groups. There's 2 different techniques, but the main drawback to both of these is if I'm clustering a whole bunch of different locations in a city, I have no idea how many groups there are, right? So that's where something like dbScan comes into place. And this is density-based clustering. So it groups together a lot of little points, and this is a form of unsupervised learning, into a nice tight cluster. And there are advantages and disadvantages to this. One of the advantages is you don't need to know how many different locations you're looking for. So in this case over here, it's grouping points within close proximity, but again, the advantage is you don't need to know how many groups. It's automatically clustered these, but the disadvantage is that you have to specify this kind of epsilon, so a minimum distance between the different points, right? So in this case, we've chosen 50 meters, but that does not a bad job over here, but over here, you're not getting the cluster and the zone that you necessarily need. So you end up with all of these different outliers. And there's another form called hierarchical dbScan. And that's really great because you don't even have to specify, in this case, a minimum distance, and it groups things nice and compact together. But the problem is, if they're too close, it thinks there's so many little groups all together. So the disadvantage is because there's no maximum distance, you end up with all these tiny little clusters. So what if we take a combined approach, right? In that case, we run first an HDBScan, and then we run a dbScan to cluster everything together. So now all of a sudden, this helps out a lot in the downtown cores of different cities where you might have 2 very close delivery points that are 50 meters away from each other. It's not necessarily good for a dbScan, but you can run this combined approach and separate things out quite nicely. And then the easy part is you run this convex hull around. So now that we've got all these different points that have been identified using the unsupervised learning technique, you draw a boundary around the entire thing, and you're able to create a convex hull. So it turns points like this into these zones that you've created, right? And oftentimes what happens is you'll find points that are very, very, very close together. It can't create that hull around it, so you can just specify like a minimum boundary and create a rectangle. And then what you do is you push your new zones really into MyGeotab at the end of the day, right? So you've run this analysis, you get all these zones that have been created automatically through just the trip data that's coming in, and you can take these zones, run a convex hull around them, and push them into MyGeotab. What I'll do right now is I'll just kind of run you quickly through a demo, and if you guys are interested at all, if you've got analysts or data scientists or any tech guys on staff, I can provide the code for this as well too. There's a full kind of notebook here leveraging Python and SQL. I can give it to you guys, and you guys can go ahead and play around with it. But if we look at these different techniques here that are being created, we have a technique here using HDBScan, and you can kind of see leveraging this technique in here. I'll zoom into a few different areas here. Let's see, up here. Okay, this is a good example. So you can see what it's done here. It's using HDBScan. It's clustered these groups together, but you can see that it thinks there's like 3 or 4 groups over here, probably about 10 over here, 1 that's clustered over here. So it's done a good job of kind of bringing them together. So what would dbScan have done in the same area? If we look at that, I'm going to zoom in here. These were preloaded to the exact right location, but it just must have resynced here. Hold on, let me get to that area again. And here we are. Dundas, and yeah. So here's that same location, leveraging dbScan, right? So if we flip back and forth between the two, you can see HDBScan has done a pretty good job of clustering them together, but thinks there's too many groups. Here, it's kind of all scattered all over the place because we had that minimum distance threshold. And now if I look at that combined approach in that same area, it kind of draws everything together quite nicely. And this was looking at, I think, about 6 months of data, of the trips data from MyGeotab for this one database. So again, all data that you would have access to as a customer or not. So you can see here what it's done is it's clustered them kind of nicely together, leveraging that combined approach. And all of this data, by the way, is driven from simple data that you would be used to seeing. So we have all this data stored in BigQuery here, and all of this data is fully accessible. So this is what we have made available in our data science package, or you guys could push to BigQuery yourselves, and you run an SQL query against this whole database, and you can see common things like the start, stop time of a trip, stop duration, idling duration, max speed, that kind of thing. So we're just taking it really from all of the trips data that you would be quite familiar with. So now once you've got all of this, these zones clustered, you have to classify them. So how do you then turn all of these random points that you've clustered, and how do you make sense of it? How do you actually tell whether it was a donor in this case or an agency? That's really what the goal of classification is. So first of all, you have to source, if you recall from my presentation earlier today, there's this notion of label data. So you have to know, you have to give the machine some form of truth data. So we have to teach it. That's what we're trying to do right now, is we're trying to teach it what represents a donor, what represents an agency, what represents a distribution center, a yard, whatever you want to call it, right? So that's what we're trying to do right now in a supervised machine learning program. And I'm going to explain to you how I did it in a very simple way, because it's the very simplest way to do it. We already have all of our zone clusters here that we've identified. So in this case, I simply manually inspected them and looked for, we had about 600 different zones that were identified. I took about 150 of them and manually said agency, donor, agency, donor. That is the brute force way of doing it. There's tons of other ways. At our boot camp, we talk about a way that we do it at Geotab that's more scalable. But the very first time we ran a machine learning algorithm, a supervised one, we actually had a summer student in, and he would classify these different zones, right? And not a fun task at all. But a lot of the grunt work, as anybody who will tell you who does a lot of AI or machine learning, is in the data preparation, right? It's getting the data ready and prepared to run these algorithms on top of. That's where 80% of your work is done. The rest of it is pretty simple. It's getting the data to the right part is the hardest thing. So in this case, I just literally went through about 120 or so of the 600 different points and labeled them as agency or donor. Then I literally uploaded that into a table in BigQuery where I had my cluster, my agency, and donor. So now I've got, if I'm looking at all of my data, sorry, there weren't 600, there were 488 zones originally. I labeled 115 of them. I labeled 60 of them as agencies, 55 as donors, and then there were about 373 unlabeled. So if I'm trying to predict what something is, I'm going to predict it on the 373. Important that the actual labels that you provide in machine learning are balanced. Otherwise, the machine is going to learn one way or the other. So 55 and 60 donors are roughly equal, so that's a pretty good way of looking at it. So in order to kind of figure out, like, how do we teach this machine to learn whether something is an agency or a donor site, or again, a distribution center, whatever type of zone you want to look at, you have to have some hypotheses around the data. What do you think is going to make an impact from the perspective of the customer as in determining whether it's a donor or an agency? In this case, it might be, is it the type of vehicle? Is it the length of time they spend stopping at a specific area? Is it the size of the zone? Is it the time of day, the number of visits, the number of different vehicles visiting there? So you have to come up with all of these different metrics and hypotheses that you think might impact qualifying a zone as a donor or an agency. So in this case, what we did is we had, this was all our trip data that you would be used to seeing: trip, hardware ID, weight class, all the different classes. And all we did is for machine learning to work, you can't have all these classifications. You can't have like a class 8, class 7. It has to be pivoted around and turned into kind of zeros and ones. So if I'm looking at this first instance here, it's a class 8 vehicle. Well, it gets marked with the 1 in class 8. So that's how we have to transform some of the data. And then we look at transforming from trips into actual clusters. So what I've done is I've moved everything from looking at it from a trip perspective to looking at all those individual clusters, those 488 cluster zones that I created, and I'm getting metrics about those cluster zones, not about the actual trip. And what I do is we come up with a final feature table. And these are the features that we think are important to determining whether or not a zone is an agency or a donor. So a few of the things that we look at here. So the unique ID column, zone 9 was visited 108 times. You know, the other thing that we're looking at, zone 6 was visited by 2 different vehicles. In this case, 78% of the time, zone 4 was visited by a class 7 truck. Zone 1 was visited 19 times with a stop times between 5 and 10 minutes. So what I did is that we bucketed it out, right? So we look at 0 to 5 minutes, 5 to 10, 10 to 15, etc. And then zone 7 was visited between 2 and 3 p.m. 11% of the time. So this gives us a good representation, some nice data to start working with to determine whether or not we're looking at an agency or a donor type of location. Then you run your machine learning model. We selected something called a random forest classifier. There are different classifiers you can use, and this is really the easy part. There's complex terminology maybe, but once you've got your data to that stage that I just showed you there, the rest of it becomes pretty straightforward. So we separate our data into kind of a train test split of 70-30%. Basically what we're doing is we're using 70% of our data to train, and then we use 30% of it to test to see like how good are my actual predictions, okay? And then we look at the feature importance. So, well, of all of these features that we've got here, all of this stopping between 0 and 5 minutes, 5 to 10 minutes, what is it that is important for me to determine whether I'm looking at a donor or agency? And the random forest classifier is really great for that because it gives you an idea of what are those important features. And then we tune a lot of parameters in our model. So in the case of a random forest, it's basically like a whole bunch of decision trees. So how many decision trees are you going to use? How many leaves at each node? So that's what we call hyperparameter tuning. And then cross-validation. So cross-validation, what that means is if I use 70% of my data to train on and 30% to test, well, I can't always be using the same 70% and 30%, or otherwise I'm going to bias my model. So I need to switch up that 70 and 30% a few times. So k-fold cross-validation means 5-fold or 10-fold. How many times are you going to switch it up to make sure that your model is working properly? And then you kind of evaluate what you're looking for in terms of accuracy. Are you looking for precision? And then you run it against all the unlabeled data. And what we ended up coming up with, actually, if I pull up this the notebook here, if you scroll to the end here, so I did my supervised learning. Here's where I pulled in all my features. Okay, I'll get down to yeah, and so what we did here is we ran our a random forest model, and then over here is where we did our hyperparameter tuning. Here it is, okay. So we ran 5-fold cross-validation, so we tested this 5 times, a 70-30 split, and when we ran everything through here, our training accuracy was 95% and our test accuracy is 85%. So what that means is that with an 85% accuracy, given these new, never-before-seen zones, I can tell you whether it's probably a donor or an agency. And what you might want to do is, I've only trained it with 120 labels here, right? So the more data you add to it, the better it becomes at learning what type of zone you're dealing with. So you can use this notebook and this methodology for zone classification, certainly in any specific customer application. We've also, when we ran it, we were able to look at a few interesting things. And so these couple of areas here, so this area here was classified automatically as an agency. So you can see it actually was a public school. This was one of those 373 had never seen before. This one over here was classified as a donor, a meat factory here, right? You can see the trucks pulling up. It had never seen that before, but it classified it as a donor. A couple of interesting things as well too. It was able to pick up some areas that weren't even picked up on Google Maps, right? So that it identified this area as a donor. The mapping doesn't even show a grocery store there, but there is one there. You know, again, another interesting thing. So if you were to use, you know, mapping as a verification engine, that wouldn't even help you in this point in time. So from my perspective, I guess the things that I would suggest, you know, to improve this model, try adding all sorts of different features. Try leveraging different models. They're pretty easy to actually add. So I tried a random forest classifier, but if you want to try a neural network or if you want to try logistic regression, it's literally as easy as swapping out a few lines of code. The key is getting the data in the right format in the first place. And then you might want to try other features like the size of the zone, the shape of the zone, and all this kind of thing that can help you identify these things. And above all, just have fun with it. So I know it was probably a little bit more technical maybe than many of you want to go. But if you have any questions, please let me know. Happy to share all that source code with you guys if you've got people on your teams or you yourselves are interested in zooming in a little bit more. It can hopefully help you guys out.